Hello students, I am Subhashish. Today we are going to learn about addition and subtraction theorem of probability. In probability, when dealing with multiple events, we often encounter situations where we want to find the probability of their combinations or the probability of their occurrence under certain conditions. This is where the addition and subtraction theorem of probability is used. Learning outcomes. After the completion of this lesson, you will be able to understand the addition theorem of probability and apply it in solving problems, calculate the probability of union of events, understand the subtraction theorem of probability and calculate the probability of the complement of events. Keywords: probability, addition theorem, subtraction theorem, union, intersection, complement. Students, let's know what is the addition theorem of probability. The addition theorem of probability allows us to calculate the sum of two events. For two events A and B, the probability of either event A or event B occurring or both is given by P of A union B is equal to P of A plus P of B minus P of A intersection B. P of A represents the events in A, P of B represents the events in B, P of A intersection B represents both events A and B occurring simultaneously. We subtract P of A intersection B, that is intersection of events, to avoid double counting the probability of both events occurring. P of A union B is equal to P of A plus P of B minus P of A intersection B. If A, B and C are any of the three events, P of A union B, B union C is equal to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C minus P of A intersection B, B intersection C. Here P of A represents the events in A, P of B represents the events in B, P of C represents the events in C. P of A intersection B represents both events A and B occurring simultaneously. P of B intersection C represents both events B and C occurring simultaneously. P of A intersection C represents both events A and C occurring simultaneously. P of A intersection B, B intersection C represents the probability of intersection of the three events A, B and C. We subtract intersection of events to avoid double counting the probability of both events occurring. Students, let's understand more about the addition theorem of probability by solving some examples. Example 1. Two dice are rolled together. Find the probability of getting a doublet or sum of faces as 4. Solution. When two dice are rolled, the total number of outcomes are n of s is equal to 6 into 6, that is equal to 36. Let event A be the getting the doublet and event B be the getting face sum as 4. Then A is equal to 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and 6, 6. N of A is equal to 6. B is equal to 1, 3, 2, 2, 3, 1. N of B is equal to 3. Show image. In both events A and B, the outcome 2, 2 is present in common. So the intersection of the two events is A intersection B is equal to 2, 2. N of A intersection B is equal to 1. P of A is equal to getting doublet by total number of outcomes, that is equal to N of A by N of S, that is equal to 6 by 36. P of B is equal to getting sum face as 4 by total number of outcomes, that is equal to N of B by N of S, that is equal to 3 by 36. P of A intersection B is equal to N of A intersection B by N of S, that is equal to 1 by 36. Now, the probability of getting a doublet or sum of faces is 4. P of A union B is equal to P of A plus P of B minus P of A intersection B. P of A union B is equal to 6 by 36 plus 3 by 36 minus 1 by 36. By simplifying, we get P of A union B is equal to 2 by 9. Therefore, the probability of getting a doublet or sum of faces as 4 is equal to 2 by 9, that is 0.22. Students, let's try another problem. Example 2. A card is drawn from a pack of 52 cards. Find the probability of getting a king or a black card. Solution. Total number of cards are outcomes. N of S is equal to 52. Let event A be the getting the king and event B be the getting a black card. Then P of A is equal to total kings. That is equal to 2 red kings, 2 black kings, that is equal to 4. P of B is equal to total black cards. that is equal to 13 plus 13. That is equal to 26. P of A intersection B is equal to 2 black kings. In both events A and B, the outcome black king is present in common. So the intersection of two events is A intersection B is 2 black kings. That is equal to n of A intersection B is equal to 2. P of A is equal to getting a king by total number of outcomes. That is equal to n of A by n of S, which is equal to 4 by 52. P of B is equal to getting a black card by total number of outcomes. That is equal to n of B by n of S is equal to 26 by 52. P of A intersection B is equal to n of A intersection B by n of S. That is equal to 2 by 52. Now, the probability of getting a king or black cards P of A union B is equal to P of A plus P of B minus P of A intersection B. P of A union B is equal to 4 by 52 plus 26 by 52 minus 2 by 52. By simplifying, we get P of A union B is equal to 7 by 13. Therefore, the probability of getting a king or a black card is 7 by 13, that is equal to 0.53. Students, let us know what is the subtraction theorem of probability. The subtraction theorem of probability is used to calculate the probability of the complement of an event. The complement of an event A, denoted as A dash, represents all the outcomes in a sample space that are not part of event A. The probability of the complement of an event A is given by P of A dash is equal to 1 minus P of A. Students, let us understand more about subtraction theorem of probability by solving some examples. Example 1. Ram daily receives 100 emails, of which 30 are spam mails. Find the probability of not receiving a spam mail. Solution. Given total number of mails is equal to 100. Let event A be getting the spam mails. P of A is equal to spam mails by total number of mails. That is equal to 30 by 100. By cancelling, we get 3 by 10. not getting the spam mail, that is equal to complement of event A, which is equal to P of A dash. P of A dash is equal to 1 minus P of A, that is equal to 1 minus 3 by 10. By taking LCM, we get 10 minus 3 by 10, that is equal to 7 by 10. Students, let's try another problem. Example 2. A bag contains total of 25 marbles in that. 15 are blue and remaining are red. Find the probability of not selecting a blue marble. Solution given. Total number of marbles in bag is equal to 25. Let event A be selecting the blue marbles. P of A is equal to blue marbles by total number of marbles. That is equal to 15 by 25. By cancelling, we get 3 by 5. Not getting the blue marble is equal to complement of event A, that is equal to P of A dash. P of A dash is equal to 1 minus P of A, that is equal to 1 minus 3 by 5. By taking LCM, we get 5 minus 3 by 5, that is equal to 2 by 5. Students, let us summarize what we have learned. Addition theorem of probability. P of A union B is equal to P of A plus P of B minus P of A intersection B for two events A, B. For any three events A, B and C, P of A union B, B union C is equal to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C minus P of A intersection B, B intersection C. Subtraction theorem of probability. P of A dash is equal to 1 minus P of A. Thanks for watching.